Okay, thanks for joining the session this afternoon. That's always the most challenging one, the one just after lunch. But I appreciate you come and you join, and I hope you enjoy the session as much as I do. I mean, it's really energizing, and we need energy this afternoon, I think, just to for the next 45 minutes slot. So as most of you were already at the panel this morning, as I said, I'm still the same. So Minh Dupuis, I'm the product manager. I'm in charge of the market management system in GE Vernova. So as I said this morning, Vernova, that's the separate company now that really focuses on the energy transition. So it's a separate company from GE. We spinned off a few months ago. Yeah, so in my role also, I wanted to say, in the product organization, I'm more the business guy in the room. So trying to identify the market trends, the growth area, that kind of things, and driving the roadmap accordingly. So I prefer to say, because if you have technical questions, I'll do my best. Yeah, I'm more on the business side. I think it was interesting for this session also to share why, from a business perspective, it's interesting for a vendor to also go in that kind of initiative and projects with LFE. So having that said, yeah, so what do we have on the plate today? I'm gonna briefly remind who we are. I've just said a few words about Vernova, but the grid software also unit in which I am, some background and drivers and challenges that relate more directly to this line ratings space, so that I can explain a bit about what we are doing in that space with LEP, so Limit Exchange Portal. And then TROLIE, which is the open API we decided to develop part of an LFE project for that portal. And then I'm going to take a step back and position LEP and TROLIE part of our broader strategy, which is GridOS, the grid orchestration software, and then some next steps and wrapping up points at the end. So grid software, that's a super commercial slide, and I did it on purpose. So what it shows, it's really the business unit where we deliver the planning, the operating, and the transactional software for the grid operators to support them in the energy transition. We have leading positions everywhere, so leading position, EMS, DMS markets. So yes, we are a vendor, we want to sell products, we want to sell licenses, we want to make profits. So why am I here, right? And that's the angle I wanted to take that presentation also. It's to explain how we use open source software, and also how we can contribute to some of those projects, and taking advantage and benefits also from this project as a vendor. Thanks for joining, Savannah. Appreciate. Okay, some background and drivers and the challenges in that rating. So these kind of mega trends, you've seen that kind of slide many times, I'm sure, showing so the increasing of weather events, cybersecurity, electricity demand, and renewables. So let me try to put this one in the context of this line rating space, especially on the renewable side, on your right-hand side. Increasing penetration of renewable, what it's going to create, eventually it will create congestion, because you have more and more of them in some areas of the grid that was not initially designed to absorb those renewables with all the variability that come with it. And congestions, is it really congestions, or is it congestion because you have some defined limits that make you believe you cannot violate those limits? So that's the question I'm raising here. Another kind of slide, you may have seen that so many times with the traditional vertical, centralized, easy to predict grid on the left, and then on the right, how it is today, much more distributed, much more dispersed. Many more players, which mean many more data to exchange, many more software, and the granularity of the software becoming smaller and smaller. Everything has to go faster. You know, all those new business processes, you have to streamline them across different players, because if it were only internally, yeah, it's a challenge, but here now you have to coordinate, to cooperate with some other players. One is missing on the top, but I didn't have the slide for that, and I could have updated though, but is the regional coordination, you know. Either it is in North America with the RTO ISOs, in Europe with the RCCs, you have also those entities to coordinate and optimize at the regional level. And again, this is one of the topics here with LEP and TROLIE, this orchestration at the regional level. So when you translate this, what those megatrends means for the digital, because we see this transformation coming. The previous slide, it shows today, but what about tomorrow? And what we foresee is in the, you know, that famous picture of the Fifth Avenue in New York with, in 1900, we have all horses on one side, and then 10 years later, it's only cars. So we believe for the grid, this kind of transformation is going to happen in the next coming 10 years. So what does it mean? It means we are at a certain point of inflection that if we do not also adapt the software, it's going to become the bottleneck of that transformation. And as a software vendor, we don't want that, right? So, so we have to move from monolithic and siloed big systems to something more modular and more federated, from obscure to secure, from managed to automated, from upgrades and updates. And I would say left and right, they are very tied together. It's really linked because the more you make your system more and more modular, obviously the more the system that was supposed to take years to upgrade will be more and more to regular updates. And there is a phrase we used to say also is, we've been building systems to last in the past, and now we are building them for change. And I have seen that, right? So I'm with GE for the past 12 years now, and I started as a project manager. One of my first projects was to deploy the National Control Center in Abidjan, in Côte d'Ivoire. And the upgrade was in 2012, and the previous version was in 2000. So it took them 12 years to decide to upgrade. Imagine. So we are moving to something more, more modular and updates. Now, question is from close to open. Okay, so for the moment, I leave that question open. This is my personal touch to this slide. It's not my corporate. The rest is the corporate slide from my marketing team. Am I recorded? I think I am. Okay. So now that we saw those megatrends, let's double-click a bit on the challenges we see on the line rating space. But the thing is, we've been operating the grid for years with very conservative assumptions, and the line limits were static or fixed. Best case, you have seasonal limits, so you update them twice a year, 4 times a year. But what it says is 99% of time, the gain is still present. But you cannot go look at for that gain, because in the system you have some limits already defined. So if you go above, it's a violation, okay? You cannot do that. Otherwise, it's many papers and many processes to justify, and etc. But the true limits are in fact far, because when there is cooler temperature, when there is wind with the right angle, the line becomes cooler, and then the capacity is higher. Okay, it is just as simple as that. So if you do nothing, it gives those forces issues, right, or problems. One is congestions. We already touched it in the intro. We have dozens of billions of costs of congestions. These numbers only in the US in 2022. We have similar estimation in UK. I think they are close to 1 billion in a year. I saw some reports from a couple of years ago. Same in Germany, obviously also with this north to south flow of wind energy creating congestions. Then also you have a possibility to defer some investment on additional lines, because it takes time, it's very costly. So imagine you can say, okay, you have some analytics tools, and you can push some line to higher capacities than what you've done so far, then you can decide to defer some investments on building new lines. Curtailment also, and that's really one point. Because of congestion, you may curtail some of the renewables, because it would create some instability. And this also, it leads to some compensation, and you have to pay the producers. And there is also the compliancy challenge. Everything we are talking about today is mainly driven by this FERC Order 881 in the US. They have a deadline by mid-July 2025 to compute the line ratings every hour, real-time forecasts, and to exchanges with the ISO and regional operator. I will come back to this. But these are the challenges we see short-term, in North America at least, in that line rating space. So, having that said, as I said, the order, it requires them to compute with this new methodology. So what we call AAR, ambient adjusted ratings. At the moment, it's only temperature, but it's a big change, because instead of updating seasonal like twice, 4 times a year, it is now every hour for 10 days. Okay, so real time and 10 days, it means 240 time points. And then we've been thinking, okay, what can we do to calculate those ratings with this new methodology? So we start to design, to build new tools. Even us, we have tools for that. And what I'm talking about today is nothing to do with that, okay? It's just the next step when you generate the rating. What do you do with those ratings? How can you be sure you will use the members, the transmission owner, transmission operator will use the right ratings in their system? And this is what it is all about, because the FERC order also requires the regional coordinators, RCs, or also ISO RTOs, to play that role to consolidate, aggregate, clear, handle with the conflicts, you know, when there are some tie lines, joint assets, different situation, exception like that, they will clear and optimize and send the line ratings back to the transmission owners and transmission operators, so they can use those validated ratings in their system for their operations. So this loop is really crucial here. So what I mean here is, without exchanging and coordinating and making sure you use the right ratings, the best tool you can have to generate those ratings, it does not have any value, you know, if you don't have that loop. So this is also an important part and driver from the FERC order to ensure those exchanges and the storage for 5 years. So this is what we've been working on. And there is an interop story we like to tell in that kind of presentation about LEP and TROLIE. So it's really the landscape typically in North America with ISO, RTOs, RCs, transmission owner operators. But you can imagine the same in Europe, you know, with RCCs and TSOs. And what happened is, okay, you have, for example, the co-ops and the RC submitting ratings, and then it will create this loop where the transmission operator will also submit the ratings to RITA. And let's just focus on this simplest case, right? Just these two. So on one hand, we have OPAL, so the operator that will compute the real-time and forecasted ratings and submit this every hour for operations to the RTO. And on the other side, the RTO will ingest this and clear that and send this back to RITA. And both of them, they have to make sure they use the same. But now the reality is not just the simplest use case. You know, we have many other transmission operators. We have many transmission owners. And we have everything I've just said about those joint assets, those tie lines to manage, all other conflicts, the outages, potentially. The RTO is aware of one of outages in one part that the other are not. So all that kind of thing, we solve those conflicts, and we send this back for operations. And then the complexity increases with, guess what? The vendors, because each vendor will come with some solution. You have and it's not everything GE or everything Hitachi. Of course, it's a complex landscape. You may have one EMS from one rating calculation from another with some sensors, etc. And so that's, again, bringing complexity. So this is why it creates some additional challenges. And there is an easy math we like to say and do also in that kind of presentation. Imagine you take just one line segment. So as I said, there are 240 time points every hour. But because you have to send and then receive, you can multiply by 2, so it's 480. And then because operators, usually they have 3 operating modes. You know, you have normal mode, then you have emergency, and sometimes more emergency 1, emergency 2, load shed. But if you average 3, it's already 1,440 data points every hour. So this is where first question we asked was, okay, are we all in agreement on the protocol to be used? Because what have been done so far is really so on real time is to use ICCP, which is really a common standard in the grid space being used for years, but it has never been designed for this kind of volume and also for the forecasts. So this is one question we asked, and then, and the 2 questions, in fact, which one can we use? Is it scalable enough? Are we using the same naming convention? Are we using the same units? Are we all aware what to expect from a party? Are we all aware what is missing from a party? Are we all aware about all those exceptions, multiple footprints, one being out of a footprint, etc.? And is all of this fully secured? So these are the new questions that came on the plate in addition on how calculate the rating. It's how to exchange and cooperate with. So really new questions on the being raised. And this is why we came with this solution. So LEP, as I mentioned, Limit Exchange Portal. And the role of LEP is really to play like a hub, you know. So I think now you get it, right, with everything I said. So a hub that will ingest and becoming the reference tool for the line ratings. And basically it has 2 main modules. One is really to orchestrate these mechanics operationally, so we call it LEP operations. Another one, which is the LEP history, to also cover the requirement in terms of storage and publication through the public portal. So it's really targeted to all those parties, primarily more for the regional coordinators, so typically ISO RTOs. But we've seen also some bigger TOs asking for it because they have large footprints, so it can also facilitate their coordination. And some of them, they also have some of their footprints out of an ISO, for example, so they are also obliged by the FERC order in that case. And more than a hub, so it's not just a simple hub, so something what I wanted to say, because we also bring all this intelligence from a vendor, the part we don't want to open too much, okay, where we make those optimization and clearing with the algorithm. So we call some services from our EMS apps, some specific services related to the line ratings to make this solving loop in the tool. So there is a crucial and native integration with the EMS for that, but also with the modeler to ingest the network modeling and the market system. And also DDLR, which is the digital dynamic line rating tool, which in our portfolio is the tool that we generate the ratings. And what is innovative with that one is, unlike a more conventional approach to use physical sensors, we do this 100% digital. So only data-based approach. So it's not the purpose of today's presentation, but we can speak at some break if you are also interested by that. And of course, we leverage TROLIE. And I will come to that. But first with LEP, what we try to do is to solve all those questions I just mentioned previously. So we solve the protocol because we use a modern API, which is common for everyone in theory, and that's the bet we do. We want TROLIE to be adopted by most of the ecosystem. Either they use GE or non-GE products. It's vendor agnostic. we support all multiple naming schemes, so we have many transposition table and everything to manage all those if you use some different naming, some different units. There is this coordination with the EMS to make this validation, clearing, etc. And it's all secured. And I will explain also in the next section with GridOS, we use a principle that is zero trust security. I will elaborate more just after. So now TROLIE. So as I said, LEP is the GE product. And what we decided to do is to create this API as an open API. And I'm going to start with the why, maybe. It's not in the slide. And this is where, from a vendor point of view, because, well, you know, it's always, open source is always a delicate topic, a sensitive question. So when we have to justify internally, oh, by the way, why would not do something open source, right? So we had to convince. It took time. But finally, I think it's a combination of different factors. So we had the chance to have one customer really pushing for that. It's MISO, Midwest, Mid-Continent ISO. And they really insisted for that to make sure the entire ecosystem is using the same way to exchange those ratings. And the bet they did is, okay, if I have all my members using this API, even though they use something else, non-GE product, it will ensure an overall interoperability. And in fact, what I noticed is when we tried to discuss the requirements with MISO and the other ISOs, it was not so much time to agree on what we want LEP to do, right? Where we spend time is, okay, now we have LEP, how do we manage all those exchanges with the members? At that time, we didn't have TROLIE. We were just wondering, there is no standard. No IEC, no SIM-like for line ratings. So either we say, okay, we do a GE one, or we open it and we have a broader ecosystem using the same. And for us, when we decided to do so, in fact, it accelerated the sales. So and immediately, so we had MISO, but then we had two other ISOs also buying the LEP, and then we had also some big TOs. They showed interest, and they finally also we sold them the LEP. I think it creates an overall confidence, and if everybody say, okay, this ecosystem will use the same API, that for us as a vendor, at the end, it accelerated also from a business point of view. And if you ask me honestly, I wish we could have done that 1 year earlier. Honestly, because the deadline is already in less than a year now, so most of the market is done. Most of the TOs, they have already decided their solution. I think if we would have come with something like that earlier, we could have done even better from a business perspective, to be honest. So what is it? Here you have finally the definition. Transmission ratings and operating limits information exchange. That's TROLIE. Mainly driven by the FERC Order. So the main goal overall is really to facilitate and help this interoperability in the ecosystem. What we want to do more specifically is to create the specification for the API. We want also to do a conformance program so that we make sure everybody we have some level of conformity when they use it. And also potentially open commons for others to develop their clients. And that's okay, you know. So it's an open standard, but it's not an official compliance standard per se. It's not an API server, okay. It is more destinated to the North American ecosystem for now. But I mean, then, especially, I mean, personally, I'm French, I'm European, so I'm also interested in knowing more what can be the use case here. There is regional coordination with RCCs. There is many things happening between, you know, aggregating IGMs, creating common models, and it already includes some of those information. But yeah, let's see, it's open. So if we identify use case for the European market too, that's also something I would be interested in, by the way. Now, I just wanted also to take a step back on how this LEP and TROLIE sit into our broader strategy as a portfolio, speaking about GridOS. So I already touched a bit about GridOS this morning at the panel. I think most of you, well, some of you were at the panel this morning. So it stands for Grid Orchestration Software. So we launched this GridOS early last year. So yeah, so let me do the marketing pitch. You know, that's the unique suite of products to support utilities in their energy transition journey. So the main 4 pillars of that strategy. One is to build AI-driven apps, but also modular apps, okay, microservices-based, so remember this first driver at the beginning, from monolithic to modular. Another one, so this is really to solve this and bring the value, reduce the time to value, and bring changes earlier with smaller updates. Federated data fabric, I'm gonna double click on this in the next slide, so just one moment. I mentioned the zero trust security with LEP. So here it's really, again, a change in mind, the way we've managed security so far in a perimeter approach. So we build some perimeters and with strong mechanisms, you know, I'm not questioning that, but inside the secure zone, then it's free lunch, you know. So zero trust, and it's again leveraging all the principles of the microservices-based architecture. The idea is to not trust anything even inside of that zone. So it means you check the rights, you check the authorization, you encrypt everything, even in the most secure zone. And then everything has to be deployable either on cloud, on-prem, or hybrid. And that's again the beauty of this kind of containerized architecture. It's agnostic of wherever you want to deploy it. One key piece of the GridOS is what we call the grid data fabric. What we believe, and this is strong conviction of our strategy, value is in the data. However, we still struggle in getting the value from this data. I don't know if you know this 80-80-80 statistics some analysts are doing, but it says that 80% of the data in any organization are dark data. So data you cannot use because of non-quality. Then there is another 80% statistic that says when you launch a AI POC, your data scientists, they spend 80% of their time in cleaning, preparing the data, 20% in science. So that's another 80. And the other 80 is at the end of your POC, 80% of those POC, they end up in the POC graveyard. You know, there is no next step. So this is what we try, we want to solve with that, how we can bring back the value to the data and limit as much as possible all this data preparation and etc. with the grid data fabric. And it's really to reconcile all those sources, either it is OT, IT, on the edge, financial system, geospatial system, external system, in a containerized architecture, leveraging microservices, composable and secured. And yeah, one last word also we like to say about that is there is an article, if you search for it in Google, for example, you search for CEO becoming CDO. It means the next CEO, but the chief electrification software tomorrow is going to be the chief data officer, because data is going to be so important. So this is what we want to solve, right? The spaghetti architecture, moving to the right. And okay, I mean, no, that's a very old diagram, you know? It's been years we see that. At least for me, it's been 20 years, you know, when I was a student engineering school. I have always seen this kind of diagram. It was ESB, ETL, or EAI, whatever in the middle. But the reality is we are in 2024, we still see that at our customers. And that's the reality. The difference is, well, what we've not succeeded to do maybe in the past is to sustain, because when you start a new project, you always have just this diagram. It starts well, and in the running phase, it's okay at the beginning, and then you start adding those point-to-points, and it's an accumulation in the time. So it does not sustain, in fact. So this is what we try to solve with the grid data fabric. And one key element of the grid data fabric, if I double-click on this component, is what we call GridOS Connect. So in fact, we decided to invest. So we acquired a company, which is Greenbird. It's a startup in Norway. And they had a very powerful box. The initial name was Utility Hive. And then we rebranded GridOS Connect. It's a box with more than 200 connectors for OT system, EMS, DMS, but also from the enterprise systems, from external devices, whatever. So this piece of the grid data fabric is really the first one. And then we have some additional features to store the data, Discover Catalog, which is a search engine, the organizer to organize all your data flows, etc., and BI to display the data in some nice dashboards and create reports. The thing is, once you have that platform, on top you can plug our GE apps, the GridOS apps, but the intention is also to open this platform to third parties. It can be partners through a Conformance program. Again, we would onboard some partners to develop their own applications. It can be customers if they also want to build their own apps on top. And that's really also, I think, one key differentiator of what we try to build here in this overall grid ecosystem. Now, what I've shown you is the grid data fabric. It's one component of our GridOS platform. And GridOS platform, it's not a business app yet. It's just the foundational platform of our portfolio. But in fact, you have other layers in that GridOS platform. And it should be familiar for some of you. It's nothing. You have the container orchestration, the security layer, the data store, the observability, and then the data fabric. 80% of the GridOS platform is just open source software. We will not redevelop things. We can leverage what already exists, what is recognized, maybe not as standards, official standard, but at least as a norm that everybody uses. So for container, yeah, we use Kubernetes as a matter of fact. If you streaming data, we will use Kafka. Database, we will use Postgre. So the approach is really to, best of breed approach. We take where the best components are and we use them. The other 20%, maybe you see grid shared applications. We see things that, because it would be a very generic platform, but it becomes a grid OS platform because we add some specific services specific to grid, but still enough generic to cover the portfolio we have from planning, analytics, EMS, DMS market. So we have common services like forecasting tool. It can be applied to any of those verticals. Modeling, simulation. So part of GridOS platform, we also build these kind of shared services to develop then more specific applications on top. But this is just the start. Until now, we have just solved one problem: how to ingest all those data and build this virtual data lake. And by the way, I forgot to mention, because we are totally distributed architecture, this is the key notion. It is federated. So we are not building a data lake per se. We are leaving the data where they are, but it's federated. But we have just solved one problem here, but it's a big one. Suppose you have this now powerful data lake. We unlock the power of that data. And what we do with that is more intelligent apps. Okay, so this is where now if we start an AI project, we have more confidence on the sustainability of it and how we can industrialize it. So we are thinking of many use cases in terms of detection, prediction, enhancement, obviously to forecast the DER behaviors, or one that I like also is how to measure and to predict the inertia of a system, because there is less and less physical inertia because of renewables. So one key point in the future is how we can predict this inertia. in the market space, we are working on more in my portfolio is the clearing engine also, how using AI to remove the non-binding constraints of a problem so that we really focus on the binding constraints and we make the clearing much more performant. So this is one example of use case we are thinking about. Okay, looking forward, back to Earth. My next steps are more TROLIE related now. And as a final slide, I just wanted to wrap up as a call to the community. TROLIE, so that's an open API. It's really open. So feel free to contribute to that project. Either you are a consumer, you can just simply use it. But if you want to critique, you can also do it, contribute, edit. That's important, especially again, as we are in Europe. I'm curious also to onboard some European folks in that project to see what we can do and identify some use cases here. In terms of progress, okay, we've passed some important phases. We have still some work to do. Anyway, you can go on the site, it's published, and we are closely working again with MISO. And actually, just to give you some contacts and links here, I think you'll get it from the website, it's published. So we have, everything I presented today is more or less public. It's extracts from some presentations and white papers on our GE website. For TROLIE, you have the page on LFE, of course, but you also have GitHubs. There is a very nice videos, a webinar also, introduction to TROLIE. And actually, my two partners in crime, Christopher from MISO and Tori, my chief architect, they are the two fathers. So I can take questions, but if you have two technical questions, then feel free also to contact them because they are the key guys in that project. All right, so with that said, thank you for your attention. I think we have a couple of minutes to take questions, and then I will hand it over to the next session. And up there. Thank you. Yeah. Daniel?
As part of the TROLIE working group, is there a working group for the TROLIE? Oh. Sorry about that.
Yeah,
for the development of these specifications, do you have a working group, and does it have meetings, or is it distributed and talked about asynchronously on the project?
Yeah, so to be very transparent, at the moment, the governance is limited to those two guys. Of course, then they more or less work on the designing, agreeing things, and then we work with our engineering and developers. Yes, that's. But it's pretty straightforward and pragmatic way of working. Keep in mind the deadline is in July 2025, so it's going to be in production in the coming month, in fact. So super exciting. But
I just lost my train of thought. What was I going to ask? Sorry.
Yeah, I have a question about, you said you are very interested in the European market. And did you talk to any DSO or TSO about how they basically solve this solution? Because I'm from a DSO Alliander within the Netherlands, and we have that hourly rate contract. We already have that in place in the Netherlands for consumers. Did you talk to them how they fix the?
No, so we've talked to them more for the way to calculate the ratings, so more with the DLR products. The way to coordinate and exchange with a potential RCC, for example, we have not.
Okay, and are they interested in collaborating? Did you find any European?
Oh yeah,
yeah. Okay.
I would be. Yeah, I would love to. If it's the next, RCC service tomorrow.
Okay.
So you mentioned that the standard isn't necessarily accepted or mandated by FERC. Is there interested in sort of advocating for that so that it does become a
As far as I know, they have not shown such interest so far, but I mean, then the more we have adoption of this, it can facilitate, I guess. I think we'll leave it, yeah. I can take question then at the break or whatever. You can find me in the hall. But I think next session will be up there from SC. So I encourage you to stay, by the way, for that super exciting session. Thank you very much.